Welcome to my presentation. My name is Zohra Baratian Qorghi. This presentation covers the investigation of diazinon residues in washing and filtration steps and during tomato paste production. I'm going to present it in four sections: introduction, materials and methods, statistical evaluation, results and discussion. Tomato with the scientific name of Lycopersicum esculentium is a fruit which is highly consumed either fresh or in various processed forms. It can affect by insect pest attack, so the farmers use diazinon, an organophosphate pesticide, for combating them. More application of diazinon can leave it in product. Unfortunately, diazinon can cause some health problems in more than 0.5 mmol. Therefore, investigation of its residue in product is more important. For preparation of commercial diazinon, we diluted 66.66 milliliters with 60% purity of it by 30 liters water and perfectly mixed in a tank. The final concentration of the mixture composed of diazinon and water with 2 to 1000 ratio. For samples preparation, we purchased 20 kilograms tomatoes from a farmer's market, then washed them individually using tap water and dried by tissues. After that, we soaked tomatoes for 1 minute in the prepared mixture of diazinon and water. After a minute immersion, we removed them from the mixture and set aside for an hour to let the diazinon residue penetrate into the tomatoes. Then we separated some of tomatoes as pre-washing samples and the rest of them passed the washing process. After this stage, we choose some washed tomatoes as post-washing samples. The remaining tomatoes followed the filtration process. The result of filtration stage was receiving tomato juice and pomace samples. We extracted 50 grams of every sample using 200 milliliters of acetone and 150 milliliters of dichloromethane in turn. Then, for removing the excess moisture content, we added 30 grams of sodium sulfate. Finally, we concentrated the final solution to 1 milliliter volume using rotary evaporator. We purified 1 milliliter of concentrated extract of every sample on a cleanup column in 30 centimeters by 22 millimeters size that previously was packed with distinctive amounts of fluorosil, sodium sulfate, silica gel, aluminum oxide, and activated charcoal. The mobile phase was acetone. At last, the final volume, 1 milliliter, acquired using the rotary evaporator to check the remaining diazinon amount. The obtained final volume of the extract was applied for HPTLC analysis. We spotted the samples extracts on silica gel aluminum plates and placed them into 80 to 20 hexane 2-acetone solvent system. After drying the plates, it was possible to make spots visible in UV chamber with the wavelength of 254 nanometers. Then we placed the plates inside the TLC scanner apparatus to determine the amount of insecticide on the stains using CASSA for software. In this study, diazinon recovery was estimated 85%. We performed the analysis on triplicate samples and the results were statistically analyzed by factorial test. The significant means were subjected to the analysis by Duncan's multiple range test, and we use MS-STAT-C software for calculation and Microsoft Excel for charting the results. You can see the amounts of diazinon residue measured in all samples in Table 1. This study showed that washing process had beneficial effect on reducing diazinon residue on the tomatoes. You can see the effect of washing process on diazinon residues in all three stages of tomato samples in Figure 1. Figure 2 shows the effect of washing process on percent reduction of diazinon residue in three stages of tomato samples. Average of these stages showed 21.29% reduction of diazinon residue. The filtration process caused pesticide divided between tomato juice and its pomace. Tomatoes contain 94% water and 60% other materials. In filtration process, the tomato's skin and seed are considered as pomace. Using this information, the pesticide residue is expected to be divided in the same ratio 15.66 to 1 between tomato juice and pomace. Our study observations showed that this assumption is entirely consistent with the facts. Figure 3 shows the effect of filtration process on diazinon residues in tomato juice and pomace samples. In the first look at the data in Table 1 and Figure 3, the amount of pesticide residue sounds higher than the one in tomato juice, but we should consider that the pomace samples are condensed and obtained from more weight of tomatoes compared to the tomato juice samples. Washing process causes 21.29% loss, and filtration process distributes the pesticide residue between tomato juice and its pomace in 15.66 to 1 ratio. In spite of this fact, they couldn't become perfect processes to remove 100% of the diazinon. As a result, it's important to give farmers enough information and warn them to not overuse the agricultural pesticide on food crops. Thanks for listening my presentation. If you have any questions or comments, please contact me by email at zbg_82@yahoo.com.